So where were we last time? We were around here somewhere, right?
Last time I was on implementations, but I don't know if that's where we were.
Yeah, we talked about the constructors. We did, let's make sure the audio is working,
We
yeah.
started push.
We were talking about push and we did expand capacity, right?
Yes, we were doing push.
Yeah.
So this is where we were. So this is the same idea as with the other stuff. If we're out of room, we will magically make it bigger. But we could have chosen, like I was saying, we could say, no, we want our implementation, we set a capacity of the stack via the array, and if we ever hit the capacity, we're not allowed to push anymore. We could do that. And in that case, our push could return a false. If we're ever at capacity, false. You might say, why would you want that? Well, that's up to whoever's making it, right? Maybe it makes perfect sense for your use case. But for our, if we ever run out of room in the array, we'll just make it bigger. We're not really making it bigger. We make a whole new array, because we call expand capacity. You go down here. A whole new array. Again, we have that funny thing, a new object array. We double its length. We take the old array's length and we double it. There's some nice reasons for that. We cast type T. Okay, now it's the T array new stack. Copy everything from the old stack to the new stack. And once we're done, return a reference to the new stack. The new stack, of course, is that new array that's twice as big with the stuff copied over, and then stack now references that. And then regardless of whether or not we expanded capacity, we do the same thing. Stack at top is the element, top plus plus, return true, because we successfully added. Any questions about any of that? I believe we talked about that last time, so this is just review, right? Couple of things. Remember, if the size is, if we have a capacity of 5 and the size is 5, we're out of room, right? But if we have an array, 0, 1, 2, 3, 4, the next available spot is size. Right? Doesn't really exist yet. But after we expand capacity, it will exist. And we just carry on. If this was size 10, well, index 5 is still fine. It's fair. Right? Sorry, capacity 10. Index 5 to add, we're good. So that's why, we just carry on where we left off. People have been asking a lot, like, okay, but why am I using the method size there? Right? You could just use the field size. You're right. Both would be fine, but the point is I had a choice to make. I could either use the method size, which we haven't written yet, we're about to write. I could use the method size, or I could reference, okay, top, right? I guess top is size. And let's just, if we go down here, there, size is top, okay? So why did I use size? I could have used top or size. I had a decision to make. Both would work perfectly fine. But why did I pick one over the other? At the end of the day, does it really matter functionally? No, not at all. But I want high quality code. One, size makes more sense to me in this context of being self-explanatory. If the size is the capacity, is like the array length, okay, I know what that means. Why? Because size is size. Top is like 1 degree removed from size. Yes, it means the same thing, but this is a little bit more direct in my opinion. Also, you might remember if you go back to the contact list example or the country catalog, the field for top was actually size. So we had size and the method size. So they had the same name. So what's the excuse there? Why use the method? At the end of the day, when given a choice to be using a field, given the choice to be using something that's private or public, use the public-facing one. Because it was designed to be used, right? Does it matter? No, but, that was the decision. Now, the same thing could be said down here. When I'm looping over the old array to copy all the stuff from the old array to the new array, in order, from 0 to length. Here, I had 3 things I could have used. Because remember, I could only ever be expand capacity if size is equal to the length. Meaning, old stack dot length must be equal to whatever size gives me, which of course is equal to top because that's what size does. So all three of these things mean the same thing. But here I chose old stack dot length. Why? All three would work just fine. They'd be functionally equivalent, but I had to pick, and I picked this. We could sit here and talk about this for a long time. At the end of the day, functionally does it matter? No, but why did I do that? Well, to me, if it was top, I would need to know that, okay, how did we get here when top was equal to length? I'd need to know more about the code. If I was calling size, again, I would need to know more about the code. Like, I would only know size is equal to old stack.length if I saw where it came from. Where here I look at this and I go, oh, well, that's just the whole contents of old stack, which is what I want to copy, right? All the contents of the old stack. That is more, to me, that's a more direct way of saying that. If you are like, no, I prefer size and here's why. If you've got a coherent argument, fine, entirely fine, I don't care. That, as long as it makes sense to you. At the end of the day, why did I pick that? There was method to my madness, but did it really matter, one of the three? Not really. All right. All right. Now pop and peek. All right, well, when we pop something, our general Java collections, when we add something to a collection, we have it return a Boolean. When we remove something from a collection, we have it return a Boolean. But a stack is a little different. When we pop something, we want to get that thing that we popped back. That's what we want. So the return type is not going to be a Boolean. When we pop the top of the stack, if it's a pancake and I pop the top of the stack, I want that pancake. That's what I want. It's going to return that pancake, okay? That's the idea. So its return type is T. If this is empty, I'm going to raise an exception. No such element exception, empty stack is the message, right? I try to pop from an empty stack. There's nothing there. What should I do? Should I crash? Should I ignore it? Should I try again? I don't know. Let's raise an exception. Whoever's using the stack can use it however they want. Okay? For us, popping from an empty stack, non-proper usage of our stack. Okay? So we'll raise the exception. Otherwise, we take the return element is stack at top minus 1, because remember, we're always growing from the far end, not 0. If 5 is where the top is, remember, top is always the next available spot. So if 5 is the next available spot, well, the spot before 5 is the thing I want to pop. So that's why I say top minus 1. I set stack at top minus 1 to null. I decrease size by 1, top minus minus, and then I return that element. That's it. We could have done that thing where I say stack at top minus minus and here equals null. I could do that. I don't like that. I like my code to be one line, one thing, you know, nice and clean. But there's our pop. Any questions about pop? I need to save reference to return element because I'm setting it to null, and then I need to decrease size, and then I need to have reference to that thing so I can return it. So that's why I'm like retrieving it and saving it to a variable before. And then what's peek? Well, peek is a much easier, or let's say simpler version of pop. If it's empty, we can't do any. There's nothing there. But otherwise, just return reference to stack at top minus 1. But we don't actually remove it. We leave it where it is. We don't decrease size. Nothing gets set to null. We just return reference to the top. We don't remove it. It stays there, but we get reference to the thing on top. Peek. Exceptional situations. Okay, what should happen if someone tries to pop or peek? Again, ignore it. Do nothing. Crash. Something else. What should be done is really, it's not part of the implementation of a stack. What should be done if you try to peek from or pop from an empty stack? That's not up to me, that's up to you. As a rule, one should follow this general design principle called like the principle of least surprise. Basically, like, well, what should happen if you pop from an empty stack? Yeah, you know what, an exception, right? Yeah.
The mic.
Thank you. I do like to wander. Consider someone using ArrayStack Flash. Should they ever expect to get nothing back when requesting the top? No, right? You always get back a reference to something of type T. If we get back null, because like, well, we could have like returned null. But that's kind of weird. Like if we're expecting to get something of type T and we get back null, I don't know. That could cause issues. Perhaps it's more reasonable to assume that the request was invalid in the first place. An exceptional thing happened. So ArrayStack is designed to be general purpose. It can be used in many situations. What should be done when calling pop or peek when it's an empty stack really depends on that situation. So we throw the exception and then you do whatever you want to do if popping from an empty stack. What this means is when I'm going to be using my stack, I'm going to be like, whenever I pop something, I want to be like, okay, is it not empty? Pop. I'll check. If we ever get to a situation where I actually call pop when it was empty, something weird happened. And we'll deal with that. And then finally, so we have our first stack. Remember, we want to add, remove. So push, pop, peek is empty in size. What are those? Well, that's easy. Size is top, and then is empty is size equal to 0. Is size 0. Return the result of this Boolean expression. Because remember, this is a Boolean operator that takes a number and a number. If they're equal, that'll either be true or false. We return the true or false, depending on what's going on. So there's our size is empty. Great. Any questions, thoughts, concerns, comments, or is this painfully obvious? We're happy, sad? Now toString. Okay, well, although these weren't defined in the interface, often we want to override the toString and the equals. So we have a design to make. We have like a design decision to make. How do we want, do you have a question or you're just scratching? How do we like, look, when we make a toString for a stack, what do we want it to look like? That's up to us. When we had a very simple object where the object was just some data, like a student object with like a couple of fields, we followed that general format of like name of the class and the fields, right? That's what we did. But now we have something a little bit more interesting, a stack. How do I want to represent it? Remember in Python, when you print out a list, it like showed you something like that looked like a list. That's how like when you print out the list, Python knew, okay, make it look like a list. And that was by like, okay, open square bracket, contents, 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 you know, commas, close square bracket for all the stuff. Someone wrote the code that said when you have a list, iterate over the list and make a string out of all the contents of that list and then print it out. Well, I mean, this gives back the string, which we then print it out. So what do we want to do for the stack? Well, this is now, it's up to us. What do we want to do? I think, to me, and you could disagree with me, and that's entirely fine. But I think what we should do is, we're going to want to like draw the stack. But what I'm going to do is always have like the leftmost thing that's like in the string that's printed out is going to be the top. Now, what this means though, is if I have an array, where's this? If I have like A, B, C, we know that based on our implementation of the array stack, C is the top. The way I want to print this is to have it be like C, B, A. That's how I want to print it. So the leftmost thing is always the top. If I were to push something new, like a D, well, I'd want that on the leftmost, right? Like I always want the left side to be the top. So it kind of like, okay, yeah, that's what I want, yeah.
You say C's the top, but when it's coding
Yes, so I mean top of the actual stack, not the field top, which is always the next field spot. Yeah. Good catch, right? That is important to know.
Yeah, that's
So that's how I want to do it. You could say, no, 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 no. If it was me, I would do it the other way where the top is always the right, it just grows like that. That's entirely fine. That is fine. This is a design decision. I think it makes sense to do it this way. If you don't agree, that's fine. It's a design decision. Now, when I say if you don't agree, it's fine, if I write unit tests that say it's got to conform to this, well, deal with it. You got to conform to this. But in general, this is ultimately a design decision. Doing it one way or the other way is not intrinsically more correct than the other. So, how am I going to do this? Well, I'm going to use a string builder. Remember, we like string builders. Because every time you concatenate strings in Java, it takes one string, another string, makes a new string. That's the combination of them. And then you do that again. Okay, it takes that string and then another new string, and then it combines them and makes a whole new string. There's a lot of overhead there. A lot of creating of objects, and computers hate that crap. So what we do is we create a string builder, which you can kind of think of as making like a list of strings, and then it concatenates them all at once. And then, okay, it's happened. We only need to make like one new string as opposed to constantly making a new string for each thing. It's a little nicer to the computer. If you were to go implement this without the string builder and just concatenating strings, you really wouldn't notice any difference. But this is, by all accounts, a nicer, better design. You have a question?
It might be tricky, but doesn't that contradict with the definition of a stack, saying that you can't access what isn't at the top?
Well, this is just for, very interesting question. So the quick answer is no, and here's why. I'll explain, but I want to make sure his question is clear. They just said, well, hold on. The whole point of the stack is you only ever access the top and like you push to the top and you pop from the top. And here now I'm iterating over it and I'm seeing everything in the stack. We're seeing the contents of the stack. We're printing out the contents of a stack, but we are never really truly able to go and mess with anything. This is just a string representation of that thing. Very interesting question, but in the spirit of where do I add something? Knowing what it looks like doesn't affect my ability to add or remove anything anywhere else but the top. But interesting question though. Yeah.
So it's about performing the action.
It's about how we interact with it, yes. The toString is just a visualization. Yeah. But very good question, absolutely. Good point. Yeah.
Can you go through like what does the insert?
Yep, we're right about to. So, here's what we're gonna do. So, typically when you do a string builder, every time you like append to the string builder, if you go back to like the country catalog or the contact list, we use like builder.append. And that would always like append, meaning in the end, I want to take all the things in the order in which I added them and concatenate them. Really, you could think of this as a list. Think of like the string builder as a list, and I'm appending a new string in the list as we go. And then in the end, I concatenate everything in the string. Insert, on the other hand, says insert into this string builder list. It's not really a list, but it is. Let's think about it like that. Insert it at the specified index, 0, the very beginning, the following value. Okay? You could think of as append is always insert at the last index this. But here I'm saying insert at the very beginning. So what I'm doing is I say if I have A, B, C, D, if this is my array, I say, okay, from 0 to size, go to index 0. The first thing I do is I say, go to index 0 and insert a comma. Okay. My implementation will always, my toString will always end in a comma, by the way. By the way. If you don't like that, we could add the logic where like the last thing will never have a comma. Screw it, it's too much work for nothing, okay? What I mean is, like if I were to draw, like, if I realize I'm walking away, but I'm loud. If I had like a list, don't think ArrayStack right now, think just a list. If I had a list and I was printing out the list, it would be like A, B, C. There'd always be a trailing comma at the end. If you're like, I don't like that, deal with it. I don't really love it either, but it's easier to leave it there. It's just a trailing comma, doesn't really matter. You have a question?
Would you not be able to use like an if statement?
Of course we could, but we don't need that. I don't care. Right? I could be like, if I is 0, don't add that, right? If I is not 0, do this. But whatever. It's nicer this way. If you really wanted to get rid of it, by all means add that if statement. Yeah, absolutely. So, what am I doing here? So, consider that this is index 0. I added it. But as soon as I add it, this is now index 1, right? So I add the comma at index 0. Then I'm saying go to index 0 and insert stack at index I. I is A. Right? But like keep in mind that like we're inserting it in front, so it really grows that way. But what I'm going to do is I'm just going to update the indices. So like this is 0, this is 1. Okay? I go through the loop. I is now 1. Insert at index 0 a comma. So this needs to move down. Comma. A, comma, right? Then I say, okay, insert at index 0, array at index 1, okay. B, comma, like they move down. A, comma, right? Do it again. Comma, B, comma, A, comma, right? They keep moving on down. And so on and so on and so on. Oh, and then, okay, I did the comma, and now the C, okay. C, comma, B, comma, A, comma, and so on and so on and so on. So now, as we go that way, we're building it this way. So this is my way to like reverse it such that the top is always here. I realize there's a D there, so let's solve that by getting rid of that D. There. Yeah.
So does this work the same way as like expanding stack, where it makes a new list every time and it changes it?
I don't know the inner workings of a string builder. It could be a link structure, it could be an array structure. I don't know. If your point is, oh, well, okay, how did this, like, what if the array? It could, it might. I don't know. But isn't it beautiful that I don't need to know? Right? Why? Because of beautiful abstraction. Yeah.
So that looks to me like it should begin with a comma, not end with one if you're building it backwards.
No, because I add a comma. The first part of the loop is add the comma, and then immediately in front of that comma put the thing. And then the loop ends. Eventually the loop will end where the last thing I put in the front of the list is that last letter.
So it doesn't print like 5, then 4, then 3, or like it's an add to the string 5, then 4, then 3. It'll add a 5 and 4 because the separator's a comma.
I'm not sure I understand. So we added A, B, C. The first thing we added, empty, insert a comma to the beginning.
Yes.
Then insert an A there, so it would be A, comma. We just go to the next iteration of the loop, I is 1. Comma B. Go to the next iteration of the loop, comma C. Loop's done because we're done. The front is a C, followed by a comma, followed by a B, followed by a comma, followed by an A, followed by a comma. We've got this dangling comma here, but that's fine. And then we turn that all into one big string, and we get C, comma. In fact, I have, this is actually a comma space, by the way.
Yeah, okay.
Yeah, but yeah, does that, you happy? Happy? Awesome. It's funny, every year, I'm always like, this is so simple, but every year half the class is like, what? And I think it's because like, we're going in two different directions, I get it, right? I think this might be a case of don't think too hard about it. Just, we're like always inserting to the front, and so therefore it grows that way. We've done this idea in Python, because we did string building in Python, but we always just concatenated strings. And one of the catalyst problems for sure was you concatenate to the front, and that's what you would get. All right, so there we go. Ideally, it's the leftmost element, however, index 0 of the stack, so for this reason, we always insert to the front with string builder. I think this is the only time where I do it this weird backwards way, by the way. Equals in hash code. Well, how do we know if two stacks are equal? Well, you'll notice a lot of collections follow a very similar pattern. Are they literally the same thing? If not, is O false or false? Is it null? Or are their classes not even the same that return false? Otherwise, okay, we can cast it as an array stack. And then we're going to use this arrays equals. We've used this before. This is a pre-existing static method that Java gives us to check if arrays are equal. What's cool about this one, though, is I can have two arrays of different sizes, but it will check the contents of this array between 0 and its size, and this one's 0 in size. So this one could have a capacity of like 1 billion, but I'm only going to check between 0 and, like, let's say this one has a capacity of 1 billion, this one has a capacity of 10, right? But there's only 3 things in it. Compare 0, 1, and 2. 0, 1, and 2. That's all. So we could check if the contents are equal, but their capacities don't need to be equal, which is kind of nice. If you're like, wait, that's confusing, we could write a for loop to do this check for us. It would be pretty straightforward. It's just a for loop and compare each inner element of the stacks, or of the arrays, right? A for loop from, presumably they're the same size. So what would this look like? Well, if I wanted to write a for loop to do the equivalence of this, first thing I would do is, are their sizes the same? If their sizes aren't the same, they're not equal. And when I say size, I don't mean like capacity. I mean, does this stack have 5 things in it and this one have 42? If they do, they're not equal. No sense comparing everything. But if they are equal, okay. If they're equal, for I from 0 to the length of whichever, it doesn't, which size, it doesn't matter. This dot size and that dot size. If they're equal, they're equal. I'd probably use this because it's this one that we're asking if it's equal. It doesn't really matter. So I decides if this dot stack at index I is equal to that dot stack at index I, and so on and so on and so on. Although I probably wouldn't do this dot stack at index I dot equals, I would probably use objects dot equals with the 2, but anyways. Or we can use this handy built-in one. We're great. It's good. Any questions about this? Yeah?
Does the parentheses around the array stack just like assume that it's an array stack because it like didn't go through that new statement?
The reason that this is safe is because, so remember, O, presumably at this stage, O is a reference variable to something, presumably because their classes are the same. Why are they the same? Because they're not the same, right? O, at this stage, must be actually referencing something of type ArrayStack. But as far as the method's concerned, it's a reference to some object, right? But we know it actually is an ArrayStack. I want a reference variable to something that's an ArrayStack. Why do I want a reference variable to something that's ArrayStack? Because if I have a reference variable that is an ArrayStack, I can ask it ArrayStack things, right? I can't ask, push, for example, because it's gonna be like, I'm an object reference variable. I might not have a push. If this is a reference variable to an ArrayStack, it's going to reference an ArrayStack, and I can tell it to push. It's happy. So what we say is, look, I know, although O is a reference to an object, I know that it really is an ArrayStack because of this. So I'm going to create a reference variable called that, cast it. The parentheses around the type is the casting. You may notice this question mark, right? What's up with that?
Yeah.
Really, what that means, this is actually interesting, is this is written inside an ArrayStack class of type T. The ArrayStack I want to check equivalency to, I don't know if its contents are type T. I don't know, right? They could be integers. They might be countries. I don't know. But I know that object is a reference to an ArrayStack, so I can check if ArrayStacks are equal. So as far as all I know at this stage is that ArrayStack, it's an ArrayStack, but what's in there? I don't know. We'll find out pretty damn fast through arrays.equals whether or not, hey, is an integer and a country equal? No, okay, they're not equal. But at this stage, we don't actually know what the type is in there. Remember, this one, I know it's type T. That one, it's an ArrayStack, but I don't know what's in there. But we'll find out by checking the equality, because the equality will check, like, imagine I go look at like a person object and a country object. Or the student object. We wrote an equals for a student object, and one of the questions we asked, is it the same type? Same with the country object. One of the questions you asked, are they the same type? So if you asked a student are equal to a country, no, false. False. If they're not equal, the arrays aren't equal, neither of these stacks are equal. It's not equal.
So does it have to be a question mark specifically?
Yes. And there is some nuance to it that we're not going to worry about. Because I end up going like, oh shit, what is it? Like it gets weird, right? But yeah. By the way, there is a funny issue with this equals that we will learn about a little bit as we go into the course. And then finally we have our hash code. What are we going to do? Well, we're going to call the objects. We're going to hash the top. What is that? Well, whenever we do objects.hash, this calls tops hash. Top is an integer. I mean, really it's a primitive type, but it'll work just fine. Okay? We get the hash of the primitive type integer. And then we take it, multiply it by 97 plus the hash of the thing at stack at index I. Then multiply that by whatever. It's the magic hash code that hopefully turns this into a unique number for every unequal array stack. All right, yeah. Any questions about that? The hash codes thing is kind of, for our purposes, it's kind of the magic. It doesn't not make sense. The idea is, I want to turn this whole object into a single integer. How am I going to do that? Well, I'm going to use the built-in method that already knows how to hash an integer. And I'm going to use each individual object type's hash code, right? So objects.hashcode, that'll be an object. And every object has a hash code method, whether you like it or not. Why? Because it inherits it from object. But you'll notice that whenever we implemented a country or a student, we implemented hash code. So this objects.hashcode, that's just like saying stack at index I, which is a reference to, let's say, a student, right? This is a stack of students. Objects at index I dot hashcode would call the student's hash code. But remember, this objects.hashcode is just that special, that wrapper one that's null safe, right? Objects.hashcode of an object just does the check. Does this exist? If it does, call its hash code. Where is its hash code? In its class's method called hash code. Yeah?
What does 97 do?
97 is a nice magic prime number that is specifically chosen empirically to help ensure uniqueness. There's probably a better answer to that. I don't have it. But it's kind of the magic. Really, one of the tricks is you multiply it by 9, and 97 reduces the number of hash collisions. I don't know why, but I've seen a graph that shows like frequency of hash collisions, and it like dips at like 97. And you're like, okay, that's the one I want, right? Because we want to avoid hash collisions. And that one, if you run the numbers, avoids hash collisions really well. Someone look up why 97 and see if we can get a better answer to that. Just say why 97, and I'm curious if like.
Okay, well, I'll do Y97 because I'm the dummy here. So I got Y97 in.
All right, fine. Say Y97 hash code. What does it say? Oh, what's up?
So what happens in a hash code collision?
It's not that big of a. Hash code collisions are inevitable because there's an infinite number of uniquenesses, but there's a finite number of integers, meaning we must have a collision. When we have a collision, it depends on what we're doing for hashing. It really depends on what we're doing, and to get into to answer your question, there's a bunch of tricks that we can do to address collisions that are so outside of the scope of this course, we're not even going to start the conversation. But it's a good question to ask, right? Usually what you would do is you use hashing if you want to create like a hash map, like a dictionary. So you want everything to map to a unique index. But if there's a collision, what do? You can't put two things in the exact same index. So what do? Well, you could do like linear probing, or you can make like a list where each thing is like, okay, whenever you have a collision, you make a linear list, right? So like, okay, sure you have to do a linear search in that linear list, but it's going to be so small that it doesn't really, there's a bunch of things that we can do, and it really depends on what we're using it for. But if we end up with a collision, we go, rats, and then we carry on with our lives, and that's that. It could, depending on how you implement things, but for us, no. Did anyone get an answer for Y97? Other than like, it's just good?
Sorry, it was odd prime
Yeah, you will. People like to do that on the internet, eh? Anyways, Y97, it's the magic number. Yeah. All right, so two ArrayStack objects are considered equal if the contents of their stacks are equal. Their stack arrays are equal. So, like the other methods in the class, the override annotation on the toString and equals and hashcode method tells the compiler that the method is overriding one in another class. However, unlike push, pop, peek, size, and isEmpty, the overridden methods are not from the stack interface, but the object class, right? So if we go through our implementation, they're all override, but that override is the overriding of the abstract methods as defined in the stack interface. These overrides are from the object class, by the way. And they're not abstract methods, they exist. So you can call them regardless. You do not need to be an expert. You're going to get enough experience doing this that it's going to iron itself out for you. By the way, if you didn't notice, assignment 2 is posted, right? So have fun. Yeah, it's a good one. I like it. Okay. Any questions before we carry on to the next thing? Yeah.
What's your favorite assignment?
Probably assignment 3.
Assignment 3.
Yeah. They're all good. Assignment 1's meh.
Yeah.
Assignment 2 is pretty good. Assignment 3 is really good. Assignment 4 I think is pretty good too. They're good assignments. I like them.
Yeah. Assignment 1 is just
Do the same crap.
do it again.
Yeah.
Instead of Java.
Yeah.
What would the objects function do when function is null? It just ignores.
Say that again. What would the?
In the equals.
Yeah.
Or in the hash code, when it checks that it's null, what would it do if it was null?
Let's go look. Probably. Let's find out. Do I have IntelliJ open? Hash code of. Hello. Zero. So this isn't if then else. This is called a. I avoid these. They're kind of handy in certain situations. These are called like tertiary operators. It's a quick inline if then else. Okay, and this is the syntax we use. Condition, what to do if it's true, what to do if it's false. So something question mark, something colon, something. If it's not null, call the object's hash code. If this is not the case, meaning it is null, return 0. Hash of null is 0. Which is nice because everything that's null should have the same hash code, and let's just all make it 0. Yeah.
An actual question this time. So for pop, why do we do top? Why are we returning, or why are we popping top of -1? Wouldn't we pop the top of it?
But remember, top is always the next empty spot. We could do it a different way. But based on our implementation, if we had an array right? A, B, C, D, 0, 1, 2, 3, 4. Top, with our implementation, if this is the state of it, top at this state is 4. Top is the number of things in this array, and you'd be like, but there's 3. No, 0, 1, 2, 3. 0, 1, 2, 3. That's 4 things, right? And it plays double duty as the next available spot. Think of it too, if we had 0 things in here. The top is 0, right? Where does the first thing go? 0, right? Try to pop from that. I can't. There's nothing there, right? So top is always the next available spot. That's why when we look at push, it just goes to top. And then we increment top after we add it. Whenever we pop, I say, okay, this is top, but the thing that's actually on top, the index of it, and try to make sure you're doing a really good job at remembering what we are implementing is a stack, but we're implementing it. So if you're like, but the top should always be the top. The top should be the top on the interface side. How I interface. Give me the top. Give me the thing on top. At that abstract level. How it's implemented, we can get as gross and dirty as we want to make it work. So how do we do it? Well, it's top minus 1 is the thing I actually care about. Yeah.
Can you switch back to IntelliJ just for a sec?
Yeah.
Like, so what's with that like evo return syntax with the question mark and the colon there?
Yeah, that's that special tertiary operator. It means condition, if the result is true, do that. If it's false, do that. It's a way to do like an if then else on one line.
Oh, that.
I don't do this. Java, the good people at Java felt they should. I don't like it. But I could write like, okay, if this, return this, else return that. That's what that means.
Makes sense.
If these start popping up in everyone's assignment, all right, fine. It's a great way to catch cheaters though. Because when you see people do that, you're like, oh yeah, everyone did that same weird tertiary operator the exact same way in the exact same spot, huh? But anyways, it's a weird one. That's what that means. Why? Because the good people at Java came up with the syntax. Yeah. It's weird, yeah. Yeah.
What if we write it like that in an exam?
On an exam? Then I'm gonna be like, why? I'm gonna probably write on your exam, be like why are you like this?
Yeah.
That's what I write. If you're right, you're right. But I'm gonna look at that and be like, of course, that asshole wanted to show off. Yeah.
10 out of 10.
10 out of
Like
10.
this.
Put a smiley face next to it.
Put a smiley face next to it. Yeah. You have to make it obvious. Like if you do, you have to make it obvious to me that you're doing it to be obnoxious.
Yeah.
If you're doing it like out of like you actually really want to do that, no, I'm unhappy. Make it obvious that you're doing it to be annoying, and then I'll be happy. If that makes sense? Yeah. Cool. There's nothing wrong with this. It's just that's what that means. It's non-typical syntax that you come across on a daily basis. See, the problem with this syntax is you had to know,
Yeah.
right? Where, if then else, whatever. Stuff like this exists in Python too, I'm certain, right? I don't use it. I avoid it. Yeah.
About the override thing, like how much should we care about that?
It doesn't matter at all. Usually IntelliJ will add it for you. It doesn't matter at all. It's just you're being nice to the compiler when you do that. That's all. All right, unit testing collections. So we did unit test. Raise your hand if you looked at the unit test for assignment 1. Of course you did, right? So if you didn't, you skipped part of the assignment. You're supposed to look at the unit tests. And what did you notice when you looked at those unit tests for the country catalog? First of all, you looked at the unit tests for the country object and you were probably like, oh, that's nice, cool, makes sense, nice, clean, whatever. Then you opened up country catalog. What did you think to yourself? Were you like, I like this. This makes me happy.
No.
No. You were like, what the hell? What is it? What's happening? Yep. Collections are stateful. They're full of side effects. They're hard. And whenever that happens, it's a lot harder to keep track of crap. So it's a lot harder to test. Okay? Deal with it. Now, if we start doing tests for these things, we're going to need a systematic approach that ultimately, I always joke, but it's not really a joke. We have coping strategies, okay? That's not a joke. That's what I'm going to teach you today. How to write the unit tests. We'll go through the topic. We won't have time today to go through all of it, of course. But the general idea is, okay, look. We will isolate various states, isolate-ish, various states of the stack. How should all these methods behave when the stack is empty? How should these methods behave when the stack has one thing on it? Sometimes we call this the singleton case. And how should the stack operate in the general case, where there's some arbitrary number of things on the stack? And sometimes we have funny edge case tests as well, but like where there's like duplicates or something, right? But we want to isolate these states, and that will help us just keep track of things. All right, so All right, there's been an emphasis on writing code defensively. Ideally, code is written in such a way that not only correct, but easy to test, understand, and reason about. For example, we like immutability. Data can't change. It makes the program more predictable. We avoid side effects. Functions and methods do not modify anything. And every function is as independent as they can be from one another. We try really hard to do that, right? You know, you might even remember back to 161, okay, we can have a function which calls another function, which calls another function, right? And we could do that, but if you can, it's kind of nice to call one function, call it 1, 2, 3, they're calling each other. But if I could call f1 and it gives me back data that I can give to f2, which gives me back data which I can give to f3, they're a little bit more independent. If that didn't make sense, that's fine. But the idea is I work really hard. We work really hard to write code defensively. One of those things is we make our methods as independent from one another as possible. It's a function that takes input, gives you back output. Test it. That's it. However, we now have collections, and this poses a problem because, one, they are mutable by their design. They are. So that's a problem. Problem isn't the right word, but that certainly makes it more difficult. They're full of side effects. They're always modifying the contents of themselves. And all of the methods are inextricably interconnected. I can't remove anything unless I added something. I can't test size if there's nothing in there. I mean, I can. It'll always be 0. All of these methods are now inextricably connected to one another. So they're not independent. So we got a problem. This is the type of programming we avoid at all costs. But we're dealing with data structures. And data structures are the way they are. All right? Now, it is actually entirely possible to make data structures immutable, have no side effects, and whatnot. We're not going to do that because what that entails is the same idea as strings, where, oh, you want to concatenate strings? You want to add something to the end of the string? No. You make a new string that's based on 2 old ones. We could do something like that with our stacks and queues. We're not going to do that. That's a lot, okay? And it's hard on the computer. So these things, by the way they are, they're hard to test. Their behavior may be different. And here's the thing too, the behavior of these methods is very different depending on its current state. They're very stateful. When I pop an empty stack versus pop from a non-empty stack, what happens? Right? Its behavior is different. What should happen when I call pop on an empty stack? Throw an exception. What should happen when I call pop on a stack with one element in it? Return the top and get back a new empty, not a new, but get back an empty stack. Pop is called on a stack in the more general case. Well, I'll return the top element and the result of the stack is changed, right? What happens differs. And this is what we'll hit, I guess, tomorrow. Tomorrow's Wednesday, yeah.